Okay, let's take a look at one last example. A jet and a small plane pass over the same point at the same time, and they are separated by 2 kilometers. The jet is flying north at 8 kilometers per minute. The plane is flying east at 4 kilometers per minute. At what rate is the distance between them changing when the jet is 16 kilometers from the crossover point? Now, this one is a little trickier because they have that vertical distance between them, but when they're talking about the distance that they're changing or the speed that they're changing or where they're going, it's looking at it as though they're keeping the same vertical distance consistently. So one is heading east, one is heading north, but we're assuming that that vertical distance doesn't change, which means that they're really just operating off of the same sort of horizontal plane, which means that I'm going to have to think of it as the jet traveling north and the plane is traveling east. Like if I had a compass lying on its side. Now, because this is changing in 3 dimensions instead of 2 dimensions, then I know that I'm going to fill this out as though it was a rectangular prism. But there are a few things that stay consistent. Like one of the things, like we said, is that the vertical distance never changes, which means that if this is 2 kilometers from where they started, then this still has to be 2 kilometers, this has to be 2 kilometers, and this has to be 2 kilometers. That vertical height is never really changing. Now, if I look at it like it was a compass, where one is heading north and one is heading east, then I would have a 90-degree angle here, which means that I have to have a 90-degree angle here. And what I'm going to do is I'm going to go directly below where the jet currently is after it has traveled a certain distance. And I'm going to connect that to where the plane currently is. And this has created a right angle triangle where I need to figure out a way to think of whatever those measurements are. Well, let's think of it in terms of the jet's change is going to be y because it's heading north. Let's say that the plane's change is going to be x because it's heading east, which means that if that is y, then that means that this is also going to be y. So I can create a right angle triangle where I have y, I have x, and then I have this diagonal. And for our sake, I'm going to call that diagonal A. Now, this is telling us what the change in the total distance traveled of the jet, the change in the total distance traveled of the plane, and what the distance is from where the plane finishes to 2 kilometers below where the jet finishes. But we want to know the actual distance between these two things, which means that we need to connect from where the plane actually finishes to, where the jet actually finishes to where the plane actually finishes, and then suddenly we've created another right angle triangle. But in this case, we have a right angle triangle that's made up of the base is A, the hypotenuse is, let's call this Z, and the height, well, it's the same height that we had to start with. It's 2 kilometers. So, when I'm defining my variables, I'm going to say let x equal the distance traveled by the plane. Let y equal the distance traveled by the jet. Let z represent the distance between the jet and the plane. And we're also going to include A, which we're going to call the distance between the plane and 2 kilometers below the jet. And as per usual, t equals time. In this case, we're doing it in minutes. All right, what do we know? We know that the jet is flying at a speed of 8 kilometers per minute. So we know dy over dt is equal to 8 kilometers per minute. We know that the plane is flying at 4 kilometers per minute, so dx over dt is equal to 4 kilometers per minute. We know that we're trying to solve dz over dt, the distance between the two. But beyond that, we also know that the jet is 16 kilometers from the crossover point, which means that we would say at this point y is equal to 16 kilometers. If we know y is equal to 16 kilometers and time is equal to distance divided by velocity, then the distance is 16 kilometers, the velocity is 8 kilometers per minute, which means that the jet has been flying for 2 minutes, which also means that the plane has been flying for 2 minutes. And distance is equal to speed or velocity times time, which means that the plane is now 8 kilometers from where that crossover point was.